Over the past couple of years, I've been making my own programming language called Faye, and in order to test out the language, I decided to make a small test game of some kind, and I ended up settling on a Space Invaders style game. We have these enemies up top going back and forth. They're dropping bombs. I can shoot, and I can destroy things. When bombs reach the bottom, you hear a little zap, and it takes off a level of shield from the bottom. You can imagine like a shield over a city that the enemies are bombarding. And when all of them are destroyed, you lose. Or if a bomb hits the player, you lose. There's sound effects. There's a relatively competent entity system in the background running all of this. There's a scene transition system for handling going between menus and gameplay. It's not that complicated, but it's built fairly well, which is kind of the point, that in order to test something well, you have to actually use it the way you would use it. We've got multiple different difficulty levels, and the difficulty actually adapts in real time to how many enemies you've killed. Ooh, hold on. Oh, there we go. I got killed. And I figured we could look through the code, talk about some of the stuff, and show off some of the stuff that the language can do, some of the bugs I hit, some of the stuff I fixed, some of the stuff I added to the language, that sort of stuff. It's about 1,500 lines of Faye code, not including blank lines or comments. This is just to make C-Lock recognize Faye. It runs with a static size in pixels for the window, and then scales it up or down depending on the resolution of the monitor it's run on. So you see here, it shows a scale factor of 3, so that means the base resolution is upscaled by 1 to 3 for this. Here's the resolution that it actually picked for the window size. And it detects the refresh rate of the monitor down to a minimum of 60. And everything uses delta time internally. I'm using Raylib because I've never used Raylib before and it looked interesting. I hit some issues. There are some things I don't love about it, but there are some things I do like about it. And it's quite easy to get started, which is kind of what I wanted, because I just wanted to throw up a bunch of bindings and get started with something. So I did. I got to. It was pretty nice. Fairly easy build process and everything. The most complicated part of the game is the entity system. The entity system needs to, well, it doesn't need to do much for this simple of a game, because you're not really doing that much. You have 5 different entity types, I believe, at this point. Where? Oh, back. Where are they? Yeah, 5 different entity types at this point. We have players, we have missiles, we have bombs, we have enemies, we have explosions. And you're not really going to have that many of any of them at a time. So you could do this in the most simple, dumb way possible, but that's not really any fun, and you're not really going to stress you or the tools you're using if you decide to do things the simple way. So I didn't. I didn't do things the necessarily complicated way, but I didn't do things the simple way. The entity system is based off of these entity lists, which has the entities, generations, a list of ranges which are dead, the current generation count, the current life count. And as entities get added to the system, there's a separate entity list per type of entity in the world. And when you add to it, it can grow this entity list by just pushing it. And when the entity gets killed, it doesn't shrink the list. It doesn't have to compact it. What it does is we track which generation that entity came into existence and died. And then we can compare it against the current generation to figure out if something's alive or not. And when entities are dead, they get inserted into the free ranges. And there's a bunch of code that handles like consolidating ranges so that when you spawn another entity, it goes, hey, I have a free range. I can go take a spot from the free range, one of the free ranges, and stick it there instead of having to grow the list. So new entities get put into the place of old dead entities towards the beginning of the list. And we can actually visualize this. I have a little visualizer right here. This will just ask the standard library to clear my terminal because we're doing some visual printing. And then we debug dump the entity list for the missiles. And in order to make this a little bit more fun, I'm going to come over here to the player. And I'm going to make it so the player can like fire every single frame. And I'm going to make it so that I can hold down the fire button. And then I'm going to go over here into enemy and I'm going to not fire any bombs. Just so that we can fire plenty of missiles and we won't die. So I'll run that. And we get some warnings because the compiler is capable of doing that sort of stuff. We'll go over here. We'll see I'm able to fire a lot of rounds. Come over here. And because I've already fired a bunch of rounds, let me actually start that back over again. There we go. Okay, so I fired a single round there when the round began. That means that out of the missiles entities, we can contain one. We have a single item free range. And this is the free range. And because we have space for one entity, the entity is currently dead and is represented in the free range. If I fire a whole bunch more, now we have this whole big free range here. And what this is indicating is like all of the entries in this range are dead so that we don't have to track like this spot's dead, this spot's dead, this spot's dead. This range from start to beginning of indices into the entity list are all dead. And we're seeing the debug information here. And this is the total number of entities that we could be storing in the list at this current length. And if I do this, you might see for a moment multiple free ranges. And then they get consolidated and shrunk and squished together as if you have two ranges that are separate and then the entities in between them die, they get combined. And all in all, the system handles dynamically changing amounts of alive entities in the scene at any given moment in order to not have to constantly reallocate, not have to constantly shuffle entities, because this means that technically you could hold on to a pointer to an entity and you're less likely to have something go wrong. You shouldn't. There's a entity handle system for you to grab a specific entity and this and that, but you could, so it's a little bit less prone to blowing up if you get something wrong. Let me undo the changes I just did so that we're back to normal. Are we back to normal? There we go. VS Code, being a very slow editor, took its sweet time to update. So we have all of this. And then we hit a crash because unsafe languages are difficult. This is some sort of crash that's happening. I've looked into this with GDB. This is happening specifically when I'm ending the Raylib drawing and Malik is getting upset in the background. This is an interesting and important thing to note, is that like this language is unsafe, but that also means that you need to be able to detect when things go wrong. And I'm not quite capable of that yet, which is unfortunate. I would really like to be able to use address sanitizer and undefined behavior sanitizers on this, but I need to add support for that into my compiler, which isn't there yet. So I can't use it quite yet. This happens pretty infrequently, and it seems to be something to do with how I'm handling sound. If I open up sound, the way sound works in Raylib is a little annoying. You load a sound file, and then you can only play that sound one time at a time. And if you try to play it again while it's still playing, it just cuts off the existing playing and then plays it from the beginning again, which isn't great. It isn't what you want for games. So you have to build your own system of like, when I want to play a single sound effect a lot of times, I need to be able to track that. It has a system called aliases where you load a sound and then you can make an alias to the sound and then you can play that. And then when it's done, you can get rid of it, or you can have a whole bunch of them and just like use those so that when you play a sound, you can play a copy of the sound that's like cheap. And so at the end of each frame, I go through all of the aliases that I've created while playing. Here's play sound. I create the sound alias, and I play it, and then I push it into the aliases list. And as I go through them, if it's currently playing, I just skip over it. Otherwise, I come in here and I unload the alias, and I remove it from the list, and then I move back through, and the index is the same, so that if like there are other ones after it, you've shuffled them down. Because this is a method on the list type in the standard library. And this seems to work. I've like written some tests, like, yes, like this is doing the correct thing. So I think this is somewhere in here is the problem, because I was working on sound when this started showing up, but I can't detect it yet. Valgrind just never completes. It never runs, and it just it just doesn't use CPU. Eventually it just hits a point where it just stops using CPU and just sits there forever. So I'm gonna, yep, there we go. We hit it. It's just not gonna do anything further. That's it. It's done. It's not gonna progress. Let me see if I can kill that. It'll catch up eventually. So we can look at some more systems. If we look at the enemy is capable of determining how quickly it fires its bombs based off of, oh, there we go. It finally terminated. Ugh. But it's able to, it knows how many enemies there were at the beginning of the level, and it's able to use that to figure out how many you've killed based off how many there are currently, and use that to boost the likelihood that it's going to like fire a bomb at any given moment. There's this fire delay thing, which is also randomized. And so that means that not only does the difficulty, actually I removed the difficulty chance. Yes, I removed the difficulty chance. Depending on how many enemies you've destroyed throughout the level, the remaining enemies start firing more. I could have implemented this through like iterating through all of the enemies and picking some subset of the alive enemies that they all shoot it, and that means that as there are fewer enemies, the same number of bombs get spawned each time. But I really wanted to be able to have each enemy be able to like fire independently on an independent timer, so that they're not all like firing at the same time. They're all kind of sparse. Each one decides to fire at a different time. Because if I come over here, there's a base fire delay, and then it creates a random amount of offset off of that, so that they all get offset from each other. And notice that consts in Fey do not have types if they're numbers and stuff, because it's just a number. And the way numbers work in Fey is that they're just numbers, and the compiler, this here's F64. It's just a 1. It just works. Same here. It just works. This is just the number 0.08, and when it gets used here, it becomes an F64. And that's handled with like very, very high precision fixed point math. So it like the compiler knows that like I can represent this, and if I can't represent this, then it'll handle gracefully. And the compiler just figures out like, this number, which does not have a type, needs to be an F64 here. I will do that. And if I cannot turn this number into an F64, compiler error is what you will get, which is pretty nice. Now, the scenes are how the game state is managed. Fei has some types, which are referred to as enums in Rust, if you know Rust. They are, think of them as a discriminated union, a tagged union, but the compiler gives you syntactic sugar and a stronger type system to make sure that you actually handle it correctly, and it like gives you niceties for handling it. Like for example here, I can match on it, and depending on which variant it is, I can just access it as that variant, and everything works. And here are all the fields on each of the scenes, which is this enum, and they're able to store fields, and when the game state changes, like you need to go from menu to menu, or from menu to gameplay, or from gameplay to menu, you transition from one scene to another. And I have this scene tracker, which just has a pointer to the scene, and then a next scene that we're going to transition to, so that at the end of the frame, the current scene will get replaced with the new scene, so that anything that you're doing that's modifying the original scene is still modifying the correct scene type. Because the scene is a sum type, it's an enum, has all these variants. Each variant of an enum in Fei is its own type. So I come down here, let's say I have this main menu variant of this enum scene. And if I come down here, here are some methods on that specific variant. And I'm able to ask the compiler for, if I have this, give me scene main menu as itself, rather than just as a scene, it's a scene main menu. And that means that in the context that all of the entities get, where is it? There it is. This is the context that's passed to every single entity when game logic happens. It has like the viewport size, all your textures, all your sounds, the delta time, that sort of stuff. But it also has the scene, specifically the scene in game, so that the entities can actually just reach in and view and modify the scene data. But it's all like statically typed. You know that it's going to be the in-game scene. And you can just go in there and like look at it. And then the scene tracker can replace that at the end of the frame, at which point, if it's no longer in game, you're not going to run all of the entities and they can't access this. Which I thought it was pretty cool little thing that Fei's enums let you do. I quite like that. Here we have the free range logic. Here's the basic logic in just text. It's fairly well commented, because this took me a while of logicking out. Let's do something fun to end this off. Let's make enemies fire lots and lots and lots of bombs. Let's do that. So if I go up here and I just say, we don't care about the likelihood of firing a bomb. We just want to fire a bomb every single time we have a chance. Every single time that we have the opportunity to fire a bomb, we're going to fire a bomb. And we are going to make that a very small amount of delay between bomb fires. We'll say 2. And then player, we will let fire very quickly. And we will make the player be able to hold down the button. And let's try that out. Interesting thing to note is that this is slower than usual because I'm recording, but this is all my code, and then this is LVM and GNU LD. And most of this is LVM. And you can see like the amount of difference I've gone in and looked at a profile of that, and most of that is just actual code gen. And I think part of that is just like the debug information. I don't have a flag yet to be able to disable debug information, so it's just always there. Oh, I can do this. Oh, it took so much longer. Well, that's a release build. So I'm gonna go over here. Holy shit. Oh god, I'm gonna lose. Yep. And I think on that note, I'm gonna end this video. I'm gonna have links to both the Fey programming language, there we go, both the Fey programming language and this game in the description. As of currently, this game does not build with the current stable build of the Fey compiler due to some compiler bugs and some standard library additions that I'm using. But those should go out Saturday, assuming I don't lose power internet from Hurricane Milton. And this does not currently build on any platform other than Linux. I have a patch that gets to build on macOS, but it dies in the Objective-C runtime because I'm not interacting with it correctly. Because that's stuff that I'm just not that familiar with. So, not perfectly cross-platform yet, but yeah. Download it, build it if you want. You'll have to build the compiler at current time, but at some point in the future, it'll be using the same version as is released with the official binary release that you can download. And maybe go take a look. Look at the code, see what you think. See what you think of the language. All right, thank you.